Stanford University.
Online design of various kinds, but most of all visualization. And we're going to be talking today about visualizing a web of data. Basically what we're going to do is kind of run through a little bit of background on what's interesting about visualization online. We're going to talk about a whole raft of projects that we've worked on over the past couple of years. And then towards the end, we're going to open it up for questions. So I'll do most of the talking, and then Tom will do most of the question answering. And feel free to interrupt if you'd like, because it's kind of more fun to have a bit of back and forth. So that's basically the entire company right there. Michael Migurski is me, Eric Rodenbeck is our founder and creative director, Tom Carden is him, and then there's the rest of the group. That's basically everybody. So everybody kind of wears many hats in the company. Some of us do mostly code technology. I'm the closest thing we have to a CTO, which means that I do kind of research projects, back-end server data kind of concerns. Other people tend to be more design or more flash or more interactive focused, but it's really a kind of many hats kind of situation. And what we're going to be talking about is data visualization. So part of how we like to talk about this stuff is by kind of tying it into things that are happening out in the world and tying it into places where people might be familiar with information visualization. Now, this being a Stanford class, I kind of assume that you guys are a little bit familiar with this stuff, but I'll go over some of the basics anyway. A lot of our interest in cartography started to come about just over like the past 5-6 years or so. And there was a little bit of a mini crescendo that happened in the 2004 presidential election, where people really started to do more sophisticated arguing about statistics and about geography and about cartography online in the form of maps connected to the presidential election. So what you see here are what's called cartograms that were done by Mark Newman at the University of Michigan in 2004. And what Mark Newman did was he took the sort of standard like Baja Canada map up there on the upper left that showed how the electoral votes played out in the 2004 election, and began to kind of tweak parameters on this thing to show how it was a not entirely accurate picture of what was actually happening in that election. So the first thing he did was he used a technique called a cartogram, which basically twists the state sizes so that they match populations within those states and produce the map on the right. So right away what you can see is that that little sliver of blue up in the northeast is actually a much larger chunk of the population than it looks on the map. Next thing he did was he started breaking it down county by county. So right away you can see that, you know, what looks like solid blue or solid red is much less solid once you start looking at it more granularly. He kind of took that process to its logical conclusion and basically made it, you know, purple cartogram that really showed that you weren't dealing with this kind of even red-blue divide picture that all the news organizations were publishing, but a much more nuanced purple America, he was calling it. Another place where we see this stuff is in what, for lack of a better word, I guess would be called Web 2.0. We're starting to see a lot of services online that are dealing with live streams of data from people that are being created on a consistent, you know, 24-hour-a-day, extremely rapid basis. This is a screenshot from John Allspaw's presentation. He's the ops manager at Flickr.com, the photo sharing website. And what he talks about is how operations at Flickr are a really crucial part of the actual website itself. In other words, engineering decisions, design decisions, various kinds of new features that go on the site are always produced with an eye towards how it's going to affect the site's uptime, the site's kind of engineering backend, the server requirements of the thing. And one of the things that he does that's a little bit of like a mind game or trick that he plays with Flickr data is by taking all of these sort of standard bits of information connected to, you know, what their servers can handle and turning it into estimated days of Flickr left in the right-hand column there. It's sort of, you know, you can imagine this visually, but it really kind of underscores what these pieces of information mean. It basically turns these kind of raw numbers on the left-hand side into something that's much more immediate. You know, they have 36 days of Flickr left at a current sort of disk utilization and network utilization and so forth. So it's, you know, it's not strictly visual, but the thing that he's trying to show here is this idea that you can bend numbers into a form that makes them much more actionable. They have 36 days before they run out of disk space or network or whatever it is that Flickr is doing. Back to political stuff, we've also seen a site called 538 pop up in the 2008 presidential election. And I think what's really interesting about this site, it's done by baseball statisticians that were taking polling data and turning it into numbers that looked, you know, starting with this kind of stuff and turning it into this kind of stuff. Basically, Nate Silver, the guy that founded the site, was saying, okay, all these polling organizations are kind of promising to tell you what's going on out there statistically, but they're not actually putting their money on the table. They're not making any kind of like bankable bets on what's going to happen. So what he did was he took, you know, information at this level of density and turned it into information at this level of density. He kind of visualized all that stuff down to just a single tiny pie chart so that you could see, you know, like what is Nate Silver's kind of bookie's view of the presidential election, essentially. And then the fourth place that we've seen this stuff happening online is from news organizations like the New York Times. It looks a little bit washed out there, but what you're looking at here is something called Casualties of War, which was produced originally, I believe, in 2005. It's a product of the New York Times that has really upped their game in terms of online mapping and visualization over the course of the past 4 or 5 years or so. And what they've done is they've taken casualty counts from the Iraq War and broken them down by, you know, you've got the age of this person who died, the race, the type of duty, the branch of the military. These are all US Army casualties. And then connected it to a map, which is not all that visible on this screen on the right, and a timeline across the bottom. And what we find really interesting about this is that the whole thing is kind of a manipulable visualization. So you can move the slider back and forward through time, look at different chunks of time, and be able to see how that affects, you know, where in the country there's big battles are happening, what kind of people are most at risk during that time. And I think most importantly, you know, they released this in 2005, but if you look at this site today, it's still up to date with, you know, last week or 2 weeks ago figures. So what they've done is they've created this interesting visualization that really boils the numbers down into an immediately graspable kind of map and timeline and bar chart form. But they've also made good on this promise to keep it live. They feed this thing with data, and any day you go to it, you can see recent, current, you know, newsworthy stuff. And that's not something that we had seen before. I think previously when the New York Times or the Post would produce stuff like this, they would, you know, they'd put a piece out, there would be an article connected to it, it would make some sort of visual argument, a lot of people would link to it, and then it would sort of slowly die and fade away over time. And I think what the Times has realized with this kind of work is that there's actually something about liveness to this information that makes it continually useful over time. It makes it something that you want to keep coming back to. So in our work, we have this kind of concept of like this iron triangle of information visualization. The projects that we work on, we like to think about aspects of liveness, live data, you know, whether that's up to the minute, up to the day, up to the week, you know, that promise of it being different every time you come back. The idea of vastness, the concept that, you know, through your web browser or your Flash visualization or whatever, you're seeing some huge expanse of data through a smallish window. And then depth, meaning that you kind of, well, it goes deep, basically, that there's a lot of data behind there. There's a lot of kind of views of that you can do. There's a lot of munging and information kind of slicing and dicing that you can do. So I've talked a little bit about liveness with regards to the New York Times stuff. Gosh, I was thinking a lot about politics when I put these slides together. This is a piece that we did about 4 years ago with MoveOn.org. It's called the MoveOn Virtual Town Hall. And what this piece did was it replaced conference calls that they were using. So early on in the 2004 election, MoveOn.org would have kind of email blasts out to people that would basically encourage them to have parties at their home or business or, you know, church hall or whatever, bring cookies, bring people, and then everybody would get onto a conference call. And on that conference call, there would be some special guest, like Howard Dean or Michael Moore or somebody else. And people found these things really frustrating. They were getting charged like, you know, $10,000 for one of these things by AT&T. And people would call in and they would basically just kind of sit there and sort of listen to Howard Dean or listen to somebody and not feel like they were part of what's going on and not feel like there was anybody else that was doing the same thing at the same time. So they worked with us to bring this thing online. The most basic feature of it was just the you know, Real Audio plugin on the upper right, which kind of replaced their entire conference call infrastructure. But then where we took this was the idea that you could actually kind of log into the site and tell them where you were. So the first thing that you saw when you came to the site was you give them your zip code and you tell them how many people are there in the room with you. And then immediately after that, they'd say, oh, there you are. You're in, you know, New York or wherever that is, or Connecticut. And then shortly after that, it would start to bring up dots showing where other people were at the same time. So right away, you go from this conference call experience, which is I'm hearing voices, but I can't tell if there's 1, 2, 200, 2,000 other people in this experience with me, to something where you can actually see that there's people all across the country. And it grows and kind of pulsates over time. So as the event goes on, what you see is tangible evidence of other people being there live with you at the same time. So if you're one of these people, the coastal liberal elite, you can see that there's a lot of other coastal liberal elites with you. At the same time, if you're somebody out in, North Dakota, maybe you feel not quite so alone. There's, W bumper stickers all around you, but you're there and you can see, okay, I'm not the only one here. Like, there's other people that are doing this with me.
What time span was that?
Like the time span of the event? This is about 2 hours.
That's why moving left sounded like it's getting in the evening where people starting to leave. Or
Yeah, so they would do these events in pairs. So the idea was that they would want to have like, a 7 p.m., 6 p.m. kind of happy hour type event. So they would do one on the East Coast, which you see here, and then one on the West Coast. And what those kind of paler dots on the right-hand side are basically the kind of ghost dots of the people on the East Coast. So if you're on the West Coast, you can see like, oh, okay, 2 hours ago, they did this thing, and there was all these people involved. And there's still, some people that basically stuck around for the later hours. But then you can also see that there's a West Coast event. So they would do these things in pairs. Not really, no. I think that we were really trying to go for simple with this. It was fairly early in our experimentation with this stuff, but the idea wasn't so much to have people visualize the exact population. It was more that sense of presence. Like, the idea was that visceral sort of feeling of like, okay, I'm not alone. There's people here. Relative aloneness, yeah, that's good. Well, if you're in South Dakota, I think it's absolute aloneness. And then the thing that you start seeing popping up here on this last slide is polls and essay questions that were being popped up by this interface. So while you were listening to the sort of, Eli Pariser or Wes Boyd or the special guest or whomever kind of talking, you would be getting these little questions popping up that would be sort of prompting you for responses. So these might be poll questions about what you intend to do. Will you be willing to host a phone party? Or do you agree with what Michael Moore just said? Or do you think that Howard Dean should do X, Y, Z? And that stuff would appear on the map fairly live. So as you're watching this thing and you're responding to these polls, what you're seeing is this constant bubbling of people's responses and then the audio feedback of that. So somebody who's working with MoveOn might be looking at that and saying, oh my God, Ohio, come on, like, raise the game here. What are you guys doing? So you can see the kind of feedback. You can see whether people agree, disagree, feel similarly to you, et cetera. The initial place where this was used was for a Fahrenheit 9/11 release event, but then they subsequently started using it for internal polling for the MoveOn organization itself. So they would do these kind of 2,000 to 3,000 person events across the country where the purpose was to essentially guide what their healthcare policy might be or what their decisions might be in a certain regard. And they would ask very direct, pointed questions. Do we focus on this or this? Do we talk to these people or these people? Should we, et cetera. The other kind of question that it could pull up was direct essay responses. So with the special guest type situations, you would basically be able to ask questions of the Michael Moore or the Howard Dean or whoever the guest was. And the idea here was sort of similar to a radio call-in show. This sort of thing would pop up on everybody's screen. People would enter in their questions for the special guest, and then there would be some sort of editorial process that basically, cleaned out garbage and approved certain responses over others, and that eventually those things would come into the audio. So, oh, Eric from San Francisco would like to know, whatever. You could also zoom in on the thing, which was kind of neat. I think something that's really interesting about this map, or that we think is really interesting, is that it's not really a new visualization method. This is a photograph of an atlas of Alberta that we have kicking around the office, and it's pretty old. It's from 1969. This thing was produced, and these ways of visualizing information were extremely sophisticated. 40, 50, 60, 100, 200 years ago. The thing that's new in this situation is the liveness, is the internetness of it. It's the fact that rather than having like a bunch of guys sitting over their drafting tables creating these things in a painstaking way over a period of hours or days or weeks, it's happening kind of on a screen as you're looking at it. I'm going to switch gears just a little bit. I'm going to talk about Dig Labs. This is sort of another example of liveness that's non-cartographic. If you're familiar with dig.com, it's a news voting website. The idea is that they have stories that users submit, and then you can vote on those stories. Because of the type of audience that they have, they tend to be stories about Linux or video games or Ron Paul during the lead up to the election, whatever that happens to be. But what we did with them was we created this lab section that essentially visualizes their activity in a live format. So it's really similar to the move-on work in that regard, where if you're just an individual user of dig.com, you're using the site, you're voting on stuff, you can see other people's numbers going up, but you don't have this like tangible, visceral sense of there being other activity that's happening online. Or if you're an observer, you might want to see where all the activity is being directed at a given time. So we created a number of pieces that visualize this activity in various ways. The first one is called Stack, which is essentially an animated bar chart. What you can see is that you've got stories represented by these bars across the bottom. Individual user actions kind of fall in from the top. And then as they stack up, you get popular stories stacking up higher than unpopular stories. And you can also dive into those stories and see what's been happening to them over the course of the previous 12 to 24 hours. So here you can see, this is a story that I think the screen cap was taken just after the election. So you've got a story that was submitted somewhere around 30 some odd hours ago. It got a little bit of activity, and then right around 12 hours ago, it bursts to the front of the page. It gets promoted in some way. It hits some sort of critical mass. And right away, you can see that there's a ton of dig and vote and comment activity that's been happening over the past 11 hours. These views of the information are fairly supple. We created about 4 or 5 of these different pieces. This is one called Swarm, where we took all of that same information, the same user voting activity, and turned it into a kind of animated, like, bioorganism sort of interface. It's the same stuff. So the idea here is that the larger circles are stories, the little yellow ones are user voting activity moving from piece to piece. And what you can see here is a movie that was recorded at the time that the iPhone was announced. So January 2007, I think. And right away what you can see is that there's a bunch of sort of smallish stories that are getting a little bit of activity, but what jumps out right in the dead center is, Apple, iPod, people looking at these stories and basically voting them up into much, much larger bubbles to show how much activity there is around those particular stories. So a lot of the feedback we got on this was either people who wanted to use it as a screensaver or journalists that were using it essentially to be able to understand what it was that the zeitgeist sort of viewed as important around that time. A lot of journalists would use this to basically kind of watch what was interesting on Dig and then potentially use that as story lead information. I guess tech journalists, because that's the audience here.
Why do the yellow things move around? Distracting.
Because a couple of reasons. One is that if a user votes on one story and then on another story, it'll attach to a story and then it'll move to the new story. So that's also the lines that you see connecting them. So as people move between stories, you get these fatter kind of...
Change their mind, you get this.
Yeah, or change their mind or just additionally vote for new stuff. And then they also fall off eventually to show that they kind of have gone stale or have disappeared after a little while. Because we're working in Flash, there was a bit of a limit to how many moving pieces you could have on the screen at any given time. So, 30 stories, maybe 100 users or so, and after a while you have to start kind of expiring things. This one was a lot of fun. You could zoom into stories here as well. Okay, leg 2 of the triangle, vastness. We've done work over the course of the past 2 years with a company in San Francisco called Trulia.com. They're a real estate company. Their focus is on real estate aggregation. So if you're familiar with Zillow.com, sites like this, basically what they do is they buy or scrape or otherwise obtain information about real estate around the country and then present it in a kind of unified form. So if you're looking for a house or trying to figure out, what kind of housing there is available in your neighborhood, Trulia would be the people to talk to. And what they were interested in was really communicating kind of how large their database was. You could go to Craigslist and see kind of, San Francisco or Boston or something like that, but Trulia wanted to communicate how colossal their database was and make people feel that they could trust the completeness of the Trulia database. So we created a couple of pieces for them. The first one I'll talk about is called Hindsight. This is a map where essentially we looked at their database not specifically of sale properties, but general residential properties and the construction dates of those buildings over time. The argument here is that there's something interesting just about the underlying information that they're dealing with, separate from the particular transactions that are happening. So what you see if you visit this site, this is zoomed into Plano, Texas, and then animated over time. You can see that Plano, Texas, I guess these are kind of fairly suburban areas, has been constructed starting at about 1980, and then, you know, presumably taking over fields and building suburban tract homes on them over the course of the previous 30 years or so. This is the same view of zoomed out San Francisco Bay Area. So starting in the late 19th century, San Francisco downtown, Oakland downtown, moving down the peninsula, basically this kind of process of taking farmland and like consuming it and converting it into housing and schools and universities and so on. The stuff that this tried to communicate and that we think was fairly successful was this idea that, you know, they have a lot of data, and rather than just creating these kind of individual views of like one particular town or one particular state, the idea was that this operated the same way as a Google map might. So you can zoom this out, zoom it in, pan around, and then share a link to those views with people that you know. So, you know, we immediately saw this activity when we launched it. Basically, people were like, oh, there's my town. It's, you know, Massachusetts, or it's Ohio, or it's whatever. People kind of grokked this idea that it wasn't a particular view, but that it was a slice of a data set that covered an entire country and was available anywhere you'd look. The project came out of a particular phase of a project that we like to call the exploration phase at the beginning. We were talking earlier about this idea that clients might not necessarily know what they want when they first come to you. So in Trulia's case, they basically said, we have a giant mountain of data. Help us figure out something cool to do with it that will get us attention and differentiate us from our competitors. So we started, this is actually Tom's work in processing, kind of a Java-like development environment for doing interactive graphics. And we started by doing just kind of individual data slices of places like San Francisco and looking at different metrics for animating through information attached to those places. So here you can see San Francisco. It's a little bit hard to see, but what you've got is just the information. You've got that slice of Golden Gate Park on the left that kind of helps you orient yourself. And it's moving over the price spectrum. So it's moving over the $1,000 to $2 million price spectrum, and you can see that it's kind of, you know, the whole of the city, and then moving up towards the hills, and then moving up towards Laurel Heights, and then finally ending up in Pack Heights, where all the really expensive houses are. This was kind of interesting, but one of the things we found was that as we looked at more cities using this particular data animation, it actually really turned out not to be all that significant, because housing prices fluctuate so wildly, especially over the course of the past 10 to 15 years, that this didn't really have the same kind of visceral understanding for people that weren't necessarily in the market for a house themselves. When we switched it to construction data, it got really interesting. There we go. So here, instead of looking at this kind of abstract metric of price, what you can see is a physical metric of construction date. So what's happening here is it's the same map of San Francisco, the same collection of properties, but it's animating back and forth, kind of palindrome style. Right now it's going back in time towards 1848, and you can see the entire city kind of contract to its like historical center in the northeast corner, and then moving forward, and you can see it expand, and there's the Sunset District and the Richmond District fill in. And they responded to this stuff really positively. It was really nice. They sort of said, okay, this is cool. Like, people are interested in when their neighborhoods were constructed, what their local kind of physical, geographic, urban infrastructure looks like and where it came from. And this turned out to be the sort of signpost towards the final site.
Destruction data?
We didn't have destruction data, no. And the data's a little bit weird in some ways. There's this huge spike at 1900, which we think is more an artifact of data collection. You know, the belief that we have is that, you know, when they started collecting this data, if anything was older than 1900, it was just like, whatever, 1900, it's fine, it's an old house.
I appear to see waves. There could be that if you compare it, there may be several paths of the construction wave.
Mm-hmm.
So that would imply that there's a destruction part or remodeling.
Yeah, absolutely. So one of the things, one of the big things that's missing.
Pull more things out of the dynamics, basically.
Yeah, it'd be interesting if, for example, you could see what the previous house on a given lot was. As a real estate company, I don't think they're interested in that, so we didn't have that information available to us. But you could imagine the kind of first wave, maybe second wave of apartments, maybe a third wave of larger apartments. I think in a city like San Francisco, maybe doesn't matter so much because San Francisco is basically on its first wave for most of the city, especially in the western half. Like most of the things that are in San Francisco are the first things to stand in that particular spot. We moved on to aerial imagery with this stuff, and it's the same data set, but now it's being overlaid on top of a satellite image. And I think one of the things that this called out to us was this idea of something we call accidental visual resonance. So what you're looking at here is an aerial photo of the 1991 Oakland Hills fire. That's Highway 24 kind of snaking from the southwest. That's Highway 13 going down towards the southeast, Caldecott Tunnel in the northeast. And really what we realized with this was that with a lot of these kind of data graphics, you can sort of accidentally end up with, missile commands, space invaders, people's homes getting blown up if you use like red or orange type colors. And you end up with this situation, which is something to avoid. So where we ended up with this was, as you'd seen before, we kind of stuck to the cooler parts of the spectrum, so it wasn't like orange, ICBM missile strikes hitting people's houses. And that was fun. Trulia Snapshot is the second project that we did with them, and this was a much more real estate focused concept. So here the idea was, okay, so we've done this general thing, a ton of people have linked to it, they're interested in the idea of Trulia having this huge corpus of information. Now what about the actual listings that we have? And with Snapshot, we kind of created this idea of the real estate magazine that moves. So the concept here is that you've got all these different properties, in particular Oakland here, and you can kind of shuffle the map around and look at it across different axes. So right now it's moving across, I believe, across time on the bottom there. So as you move left and right, it's looking at older and then newer houses. But you can also say look at price gradients, or you can look at construction gradients. And what happens is it basically moves around and then shows you the different properties around town. So this is the way of trying to see like what's actually out there in terms of property listings, but in a very dynamic visual sort of way. Like how do you browse this thing so it's more like a, I don't know, almost like going to the candy store and picking out houses rather than this sort of dry, like I would like 2 bedrooms, I would like 3 bedrooms sort of process. Yay. The third leg of the triangle is depth. This kind of gets into some of the more recent cartographic work that we've been doing. We did a piece called the SF MoMA Art Scope with the San Francisco Museum of Modern Art last year, where we really started exploring this idea of cartography and slippy maps as a metaphor for browsing through non-cartographic information. So this is a screen grab of Terra Server from about 2003, 2004. This is the first place online where I was able to find reliable satellite imagery for the entire country. And this really illustrates kind of what happened in early 2005 when Google Maps flipped the web upside down. You had a situation where you could look at all this information, the satellite photography, but you had to use these arrows to navigate around. And it was really kind of a form-based, like click the button, wait kind of interaction. And what Google Maps did was, they produced the same information, but now it's a much more fluid kind of panning, zooming interaction. You're probably all familiar with it, so I won't belabor the point, but the idea is that, it's rather than click, it's pan, and rather than click, it's zoom. The way that Google Maps accomplishes this is by breaking up all of their cartography into tiles. So the images are served as these little 256 pixel wide squares, which are basically put together on the browser side. So as you move around, the browser requests the next row or the next column of tiles, brings it in, and gives you this convincing illusion of having a map that you can pan for thousands and thousands of miles. What we did was we took that same idea and applied it to the SF MoMA's art collection and created a visual browser with this kind of loop interface where you could basically look at their entire collection of information, or their collection of artworks, I should say, or at least the subset of the collection that they have the rights to do mechanical reproductions of. It's about 6,000, 5,000 pieces or so, and then pan and zoom around it as though it were a map. So here you see the zoomed out version. Here you can zoom in a little bit. Here you can look at individual pieces. You've got the kind of overall sort of globe viewer on the upper right-hand side there. You can search based on keyword, artist name, click around, go from one artist to another. The concept here is kind of taking this whole browsing metaphor that Google Maps made really common and public and interesting and apply it to a different data set and see if that works. And we've gotten a lot of good feedback about this. Modest Maps is a library that we created in order to do this stuff. So one of the reasons why we got so interested in these sort of slippy, zoomy, tiley maps is because we've been writing code and kind of constantly iterating on code that helps us perform this particular kind of interaction. So we've done it for maps, we've done it for artwork, we've done it for other types of information. And where that came from was a research project called Oakland Crimespotting. I think I mentioned before that one of the ways that the studio works is that we tend to do kind of a combination of research projects and commercial projects. It's nice if people can't tell which is which, because we like the idea that everything kind of has the same attention to detail given to it. But the concept is, if you do something that you enjoy and you do something that you want to get paid for, like this, then people will come to you and basically say, okay, so we saw this research project you've done. Can you apply this to, my data, my home, my city, my government, whatever that is? We chose Oakland because I live there. We chose crime because Oakland has kind of a lot of crime. And we chose the project, I think more generally, because Oakland's own crime communication system isn't very good. So if you go to the actual Oakland police website and look up their GIS crime information, you get something that looks like this. It's a little bit cartoonish. It's a little bit hard to deal with. It doesn't have the same kind of slippy map affordances that Google gives you. It gives you these really cartoonish little icons on there. So you've got like a purple spray can for vandalism, 2 different colors of boxing gloves, depending upon whether it's aggravated or simple assault, a little syringe, a little knife. Prostitution is a big pink P. There's one up in the upper left. It's a little bit comical, and I think it's also kind of unfortunate because the way you even get to this map is you go to their site, you agree to a disclaimer, you tell them what space you want to look at, you tell them what time span you want to look at, you tell them what kind of crime you want to look at, and then finally they give you a map. It's not very pleasant. It's not like Google Maps. It's not like other websites where you basically go to the site, they give you a map, and then you figure out what you want to do. It's sort of like you get this kind of 20 questions, third-degree Spanish Inquisition at the beginning. Kind of unfortunate. I mean, it's the actual police data. Yeah, it's got coverage. It's the real stuff. But like, you can't link to. Oops. You can't link to this view. Once you get there, you can't like copy what's in your URL location bar and send it to somebody. You basically have to call them and say, like, okay, click on the site, go to the thing, press the button, do the thing. All right, now you're done. So it's a really sort of tedious way of looking at this information. And I think it really violates some of the current writing on this topic. So we've got a friend of ours, Tom Coates, has a talk that he calls Native to a Web of Data. Another Brit, Matt Biddulph, talks about designing data for reuse. And what these guys are really focusing on is this idea that information published online should really be online. It should have a URL that you can copy paste. It should have views that you can share amongst people. It should show you information rather than kind of bake the information into these abstract pink P type images. So what we've done with Oakland Crimespotting was kind of think about how this data gets represented as data and then as a map. So one of the things we do that the Oakland site doesn't do is to produce individual permalinks for every single crime that happens. So here you've got a murder that happened on a Wednesday, March 5th in North Oakland. It has a permalink. It's got a URL that's like crimespotting.org/ID number. And it's possible to copy that, paste it, share it with somebody else, look at other crimes that are similar to it. Basically, all of this stuff is like a regular sort of web page that anybody from 1993 might be familiar with. It's this idea that, to put information online in a way that's maximally useful to people, you kind of tune it all the way down to the like Mosaic 1.0 era, and that will help people sort of build up from there. Other thing we do is we provide the actual information in its raw form. So in thinking about things like data APIs, we thought about what do people who aren't sort of XML, Python type nerds view as a data API. And one of those things is basically Excel spreadsheets. So in addition to the information in a mapped visual HTML form, we also offer these downloads for people. And we've gotten great feedback about this stuff. I mean, like one of the nicest things that anybody said about this site is they used to go to their neighborhood crime prevention meetings and the police officers would bring like a spreadsheet and say, all right, here's all the vehicle thefts that occurred in your neighborhood in the past 5 days. And they would say, okay, where did that happen? Where was I, et cetera. They would basically have to respond to new data with the police in the room. And now what they do is they download these things, they figure out what's been happening in their neighborhood, and then they come to the police with questions for these meetings. So rather than seeing information for the first time, everybody's talking about things that they're familiar with and talking about data that they've all had kind of time to get comfortable with. And they said that the meetings just go, they're just more productive, I guess. So this is what the actual interactive map looks like. This is the first thing that you see when you come to the site. What you're looking at is basically west and north and central Oakland. You've got a time slider widget down here. We actually gaffled this idea from Jeff here. Where is he? This is something that we call or that he calls a scented widget. The idea is that, it's the widget that offers you the ability to navigate through time, but it also has information about what you'll find when you get there. So you're looking at sort of a combination loading bar / bar chart for how much crime activity there is / interactive piece that tells you how to get there. Across the bottom right-hand corner, you've got all the different kinds of crime that are available. So red is for violent crimes. You've got aggravated assault, murder, robbery, simple assault. Blue is for like quality of life, prostitution, drug kind of stuff. And then green is for property crimes, theft, burglary, that kind of stuff. You can zoom out. You can zoom way out. And then you can learn all kinds of really cool stuff from it. So one of the things that we've learned from it that's really interesting is the general distribution of crime around the city. So if you look at it, sorry. It's everywhere. It's everywhere, yeah. Well, it's not everywhere. That's the interesting bit. So it's kind of everywhere, except you've got that whole slice above the 13 on the upper right-hand side that doesn't seem to have very much at all. And that's essentially where the parks and rich people are. If you look at the property crimes, so this is like car thefts, for example, those kind of extend over most of the city up to the 13 and then not very far above. But if you look at the violent crimes, they're much more limited down below the 580 freeway. So you've essentially got this kind of flats versus hills division in Oakland that comes out of the data here in a way that we don't think is entirely apparent the way that the Oakland police publish it. The other thing you can get an insight on that's really interesting, this is zooming into East Oakland around the Fruitvale BART station. What you're looking at here is 580 freeway on the upper right, International Boulevard, and then you can focus just on the prostitution arrests using this kind of Apple spotlight metaphor, and then show nothing but those. And what you see if you look at these maps over time is that you've got a lot of crime that's like a crime of, I want to say event-driven crime. In other words, if you get robbed, you call the police, that's when the robbery is marked for. But for things like prostitution and drugs, oftentimes it's the police that are taking the initiative there. So you'll get 0 prostitution arrests over the course of 2 to 3 weeks, and then you'll get the situation where you basically have like, 6 p.m., 6:30, 7, 7:30, 8, 8:30. They basically start at one end of the street, drive down, arrest a bunch of people, and then they forget about prostitution for 3 weeks after that. And we see these in 2 places in the city. We see these on International, and we see these on the west side on San Pablo Boulevard. And we like this idea that there's some things that are kind of police motivated and some things that are more response motivated. The third kind of pattern we see that's kind of interesting is the distribution of the types of crimes that are neighborhood driven, I want to say. So here you have West Oakland. Here you have violent crime, which includes robbery in West Oakland. And you can see that it's really kind of spread evenly all over the place. But if you look at drugs specifically, they cluster much, much more tightly into that triangle just south of MacArthur Boulevard. I think what's interesting about this is that if you know anything about these neighborhoods, you kind of can tell that like that triangle up there is really kind of a bad neighborhood. Like it's a really awful spot. A lot of flop houses, a lot of like single resident kind of hotel kind of stuff. And so there's a lot of just nasty drug stuff that happens there. But then the rest of West Oakland, while it's, not the greatest place, it's kind of downtrodden, it's at least working class. Like people here will own their own homes or rent homes. They'll be a lot more stable. People have jobs. It's a real functioning working neighborhood where that other slice isn't quite so much. And so you can kind of see that in the distribution of the different kinds of crimes. Time of day? Not currently, but we're working on some extensions to this stuff. I'll talk about one of them, and then I guess time of day would be the one that I don't talk about, but is awesome as well. Where we're taking this is to look at it in terms of much broader statistics over time. So all the views that you've been seeing have been kind of particulate. You can see, a crime, a crime, a crime, a crime. You can look at it up to a month at a time. And what we're thinking about is how do you represent this stuff in a more heat map type format where what you're looking at is like 6 months worth of data. Additionally, we're trying to think about how to improve the heat map metaphor in general. So one of the things that we find frustrating about the state of heat maps online is that a lot of times basically what they tell you is more or less, but they don't tell you how much more or how much less. It'll be like yellow for like lots of crime, but you don't actually know what that means. Like it doesn't really give you a picture in your head of what does a lot of crime mean. Does it mean that there's like sirens everywhere, or does it mean that once a month I might get robbed on my way home from the BART station. So what we've been thinking about here is how to use color to really communicate specific tangible things. So, sorry about the projector. The places where it turns from green to orange are not just higher, but they're specifically places where for any given city block, the cops come to that city block once per month or more. So if you live on a block and the cops are coming every single month to your door, which is actually kind of a lot if you think about it, because that's like, once a month to you, once a month to your neighbor, once a month to your neighbor down the block, et cetera. It's actually kind of a high level of activity. And you can see that there's, places around, for example, the BART stations and around that chunk of, narco land up there in the upper right where there's a lot of activity. It's really heavy. And then there's a lot of places where there just isn't that much activity. And if you live in these spots and you can kind of pinpoint your house, you can basically see, okay, this makes sense. It's, it's every month, it's every 2 months, it's every 3 months. One of the ideas that we're trying to explore here is this kind of, like hard drive manufacturers talk about mean time between failure, like how long you can expect this drive to run before it explodes. And that's basically what we're thinking about here. It's like, how long do I have, given that somebody just got robbed on my block, until the next time something like that happens? How many times a week do I have to kind of watch my back in this part of town? And it happens at a lot of different granularities. So this is a really specific, almost per block heat map, but you can pull it out a little bit. Hello? You can zoom in, and then you can kind of pull it out and look at lower granularity. So for example, you've got, kind of specific down to the block level, and then a little ways out, and then a little ways out, and then a ways out. And so this can kind of give you this consistent sort of view of like a general neighborhood, a specific block. This kind of view might be appropriate for like an entire neighborhood of fairly kind of uniform type housing. But if you have a situation where there's a freeway cutting through a neighborhood and like bad crime on one side and decent, okay, not so bad crime on the other side, that might be something that you could see from one view and not another. So where are we going next with this stuff? So this is a very recent, this is the last project that I'll talk about. One of the things that was kind of opened up in this situation was this idea of kind of getting away from the Google Maps data set and looking more at open data sets like OpenStreetMap. It turns out that street information is actually fairly hard to come by, and there's a Wikipedia-style project called OpenStreetMap that Tom had a hand in founding in England a couple of years ago that's looking to basically crowdsource the creation of street information for around the world. And this has been super interesting to us because it means that we can do a lot more visually sophisticated renderings of streets. So this is a project we did for a company called CloudMade that's explicitly trying to commercialize OpenStreetMap data through the creation of maps that compete with Google, compete with Microsoft, compete with Yahoo, et cetera, in an open way. So these are maps where the visual sophistication is designed to communicate something helpful or help you get around, but at the same time, as a regular user, you can get into this data and say, no, actually, this street's closed now, or there's a park here, or there's a school here, or, that river's been drained or dammed or something. So we've created all these different visual styles for their work. This last one is something that we called Midnight Commander that we had a lot of fun working on. It's basically just kind of trying to communicate the different variety of ways that you can present geographical information. If you look at your typical Google Maps mashup, you'll get those kind of acid, hot, orange, yellow freeways and yellow roads and bright, bright green parks. And it's, you can find your way around, but it might not always be suitable for putting information in front of or behind, where some of these other types of cartography just sort of open up that possibility that there's something else out there. And so I think to sum up, really what we're looking at is a situation where data is getting more available, more free, more open, while at the same time the possibilities of how design is communicated online are kind of raising the game in some ways. You've got like better Flash plugins, you've got better JavaScript stuff that's happening in browsers. These sort of two pillars of design and information are moving towards each other and really creating a situation where better, nicer, cooler, more open stuff is happening. So I will now open it up to Tom. Thank you. This is question and answer time.
So one thing that is interesting is you showed a lot of map stuff, and it seems like most of those maps, you're imagining the user was sitting in front of a desktop computer. Have you thought about doing live, vast, and deep for users where the map is in their pocket or on their dashboard or somehow mobile?
Yeah, definitely. Can everybody hear me okay? I just attach this, yeah, okay. I mean, a friend of ours, Adam Greenfield, when he first saw Oakland Crimespotting, the first thing he said was, I want this in my pocket, you know. He wanted to be able to pull out his phone in Oakland, which I don't know if it's the greatest idea to come straight out of BART station in Oakland and pull out your phone, but he wanted to be able to pull out his phone, glance at the display and say like, you know, is this a safe neighborhood? Am I going in the right direction? And he wanted the kind of information that Mike's been working on with the heat maps recently, this kind of, you know, crimes per week or how long between crimes in this neighborhood. He wanted that kind of information with him wherever he went. So it's definitely the kind of thing we're thinking about. It's not the kind of thing we've done yet. In terms of taking these things and making them be about where am I now and not about where should I go. So we don't have specific examples of what we've done so far, but it's definitely something we keep talking about. Yeah.
One of the other non-geographic pieces of data set that you were talking about was the SF-MoMA stuff. And I wondered what kind of locality you were able to project into the data to let people look at it, so that you might be interested in, you know, arrange this whole set of 6,000 visual artifacts by style or by, you don't want to do it alphabetically by artist, except that it does bring each artist together.
Yeah.
But you might want to do by timeline or, you know, lots of different views that you might want on that.
Yeah, we did a bunch of different orderings. Because the thing was rendered into images on the server side, we didn't open that up as a variable you could play with in the interface. And the one we picked ended up being acquisition time, or the date of acquisition for the museum, which is kind of, it was a nod to the fact that the process that produced the art scope was this kind of conversational back and forth with us prototyping interfaces and the curators at the museum taking a look at it and responding to it. And one of the things we found was the more nerdy we got with you know, the aspects of the artwork in terms of sorting them over time or by genre or whatever, the better they responded to it. But at the same time, if we'd gone fully with that approach, we would have been indulging them and not their audience. But we did leave it in that the order was acquisition date. And that gives you these streaks where a new curator came on and acquired 24 architectural drawings. And they didn't have any architectural drawings before that. So there's this like run of white images. But I mean, it was essentially arbitrary. We didn't want to randomize it. But at the same time, we couldn't open it up, so we had to pick one, and it was acquisition date.
And so then you talked about being able to filter. Once you filter, do you get a grouping that makes sense that lets you browse usefully?
You get a path around the artwork, so you can jump from place to place. We don't filter it down to a subset again because those tiles are static. If you've experimented at all with the work people are doing with Microsoft's Deep Zoom stuff, it came out of the photosynth research that they acquired. I think Sea Dragon was the product originally. If you take a look, they did something with the Hard Rock Cafe where they visualize all the memorabilia of the cafe, and the interface looks very similar. They'll actually let you filter it down to a subset, but we haven't done that yet. Go ahead.
This is sort of a mechanical question. You talked about the tiles, like whether it was Google Maps or whatnot. Obviously, if you're at a greater level of zoom, it's more tiles. That tile is the backdrop, and now you have to put the dots or the balls on it. Kind of like you pinned a skin on the wall, and you have like 4 longitude lat, and then you're just doing an XY plot, or is there, like, or are you doing it by something where, yeah, or like the coordinates of the street data, and in other words, is it 2 totally separate processes, and then you just stack one on top of the other?
I mean, when we're using Google's maps or Microsoft's maps, then we've derived the projection that they used to position their the lat-long streets have been projected and put just so on the map. So we're using the same projection they use, and that's run client-side. One of the reasons Google's maps and Yahoo's maps and Microsoft's maps all line up perfectly, they use the same tiling scheme and the same map projection. They actually use a simplified version of the Mercator projection that stretches the globe out into a square. And they all use the same one because the equations for that, when simplified, are really fast to do in JavaScript. So the data comes across, any data that's going on top of the map comes across in latitude, longitude pairs. And those get projected in the Flash client or in the JavaScript client and placed on top. So yeah, it is like 2 sheets.
But like the thing that you Oakland, you weren't using that, right? Was the backdrop something that was abstracted, and you, like, how did you get that into something that actually achieves the same result?
The backdrop for that is Microsoft's Virtual Earth map tiles. It wasn't Google Maps, but it's an identical thing, essentially. They're interchangeable there.
Is everything that you're doing with maps using that?
Almost everything we've done in the last 2 or 3 years has been done with tiled maps. Because of this issue Mike mentioned, getting hold of the vector data in a way that you can distribute online, not only is it more difficult to distribute multiple resolutions of that data, it's also difficult to get a license to distribute it online. So what you find is that as soon as there's a product like Google Maps that kind of abstracts that problem away from you and gives you multi-resolution tiled imagery, you use it and you worry about something else. What we're seeing now, though, with projects like OpenStreetMap is that people are crowdsourcing vector data, and it's cheap enough, and it's being presented in a way over APIs that's accessible to web developers. So I'm pretty sure you'll see more of it. You see it already in routing applications where people won't have the vectors for absolutely all of the map. But if there's a particular route they want to highlight, Google Maps does that, where they will use vector data for the route. And you'll see that more with buildings and so on this year, I think.
Sorry,
no, go ahead.
For something like the New York Times, when they have the election maps, which were a flash type thing, and it's an abstracted map. Totally different, all like all counties, and it feels.
It can be a different method to present things like county level visualizations, in a web browser. It might not be, though. You can use tiled data for those, and then apply a map to the palette. So you can pick out particular shapes in image data and change the color. But I think they use vector data for that. Yeah. Yeah. Cool. Anybody else? Yeah.
Just another question about tools. It seems like you guys use Flash for most of the stuff that you've done, but then I think there was one project you worked on that was done in processing. Mm-hmm. And I was curious, how do you guys choose to use the tools that you're using, and are there any new ones that you're thinking about?
Absolutely. I mean, most of the time we use Flash because most of the time we want stuff to work online. Most of the time we're under extreme time constraints and pushing the amount of information we can manipulate. So Flash still has that sweet spot, and they keep, with each new revision, it stays just a little bit ahead of web browsers in terms of a uniform experience, predictable experience. So because of the fast turnaround of our projects, and because we want to manipulate as much information as we can interactively, we stick with Flash. We have used processing in the experimental stages of our work. We used other interactive visualization tools as well, but we don't tend to deliver final work in anything other than Flash because of those constraints around wanting to deliver stuff online. Increasingly, we're using more server-based processing, more pre-processing of information, and we're looking now at the current generation of web browsers, especially with an eye to interfaces that will work on mobile phones, on iPhone and on Android as well. So I wouldn't be surprised if we'd, not use Flash this year certainly, and if not, then next year.
Yeah, we're sort of waiting for browsers to catch up. Just like, almost as a metric, like number of dots you can stick on the screen and move around. It's like Flash can do like 10 times as many as JavaScript, but there's a million smart people like at Apple and Google and a bunch of other places that are thinking about how to raise that bar. And as soon as it gets someplace acceptable, I'll just jump ship.
Yeah, we're certainly, we use Flash kind of begrudgingly. You wouldn't find us giving a presentation with Adobe logos at the beginning, like some people might. So we're not an Adobe consulting business, but we are, users and abusers of Flash at the moment. Jeff.
Yeah. So one of the things I find really interesting in your work is across projects, a number of the different types of editorial decisions you make in your design, whether it's for a massive data set, which slices of the data to show, maybe others to leave out. Or in the cases of things like Dig Swarm, I can imagine many other types of visual representations that might actually more effectively communicate all that's happening in the data. But because of trade-offs with user experience or other concerns, you choose maybe perhaps a representation that doesn't show as much. And so I'm just curious how you work through those questions, and maybe there's a process behind how you make those decisions.
Yeah, I mean, our advisor, Ben Saveni, compared our work to fashion in some respects. It'd be kind of bad form for us to do the same thing twice. With the map work, that gets hard, right? You're using commodity tiles. Like Mike's saying, like most of the work is dots on the maps, and then the context around that and the delivery of that and allowing people to pass it around and share it. But as far as things like Dig Labs go, you know, there was a fairly deliberate decision not to go with, say, the force-directed graph approach to navigating through connected data sets. But I think also with Dig Labs, it was this liveness that dictated all of those views. So there's new information coming in all the time. And I think that's, you know, apart from making sure there's some character to it that gets it attention and gives it a life of its own in terms of conversations around it. And that's the fashion aspect. I think there's also the liveness aspect that drove those changes. And I didn't actually work on those original Dig Labs pieces, so maybe Mike has more to say about
one of the interesting things about the Dig pieces in particular was when you start dealing with live data, you're really beholden to the patterns that it has. So like with Dig, for example, they have users in Europe. I think it's changed now, but in 2006 they had users in Europe, users on the East Coast, users on the West Coast. And because of like dinner hour and time changes, basically at about 5 or 6 p.m. our time, like all live activity on the site would basically slow to a trickle. So we almost were only able to work on those pieces, you know, during times when people in like the East Coast or the West Coast or Europe were either like, you know, on their computers in the evening or on their computers in the daytime, but not during dinner and commute type hours or sleeping hours. So it was interesting that like the slice you choose is almost dictated by factors well outside of your control in a lot of these situations.
Yeah.
Sort of getting back to Scott's question about sort of working towards in situ cartographic interaction. When you're doing your sort of use case considerations and working towards what might be kind of common between desktop and out in the fields, some notion of actionability. How do you sort of come up? How do you do use cases with actionability within some kind of process? I mean, you know, there's the crime process, you know, with victims that live on and so on and so forth. There's the impact on the community, this sort of stuff. And you're sort of presenting a visualization that touches on the commission of the crimes, but there's a larger context, actionability, or the use case might want to address that within the context.
Yeah, I think with some of our work, the initial steps are all about illustrating what we know, and they're not really about making decisions based on that illustration. So first of all, we're just like, okay, what do we know? What does this look like? You know, then once we're presented with that, there's something to respond to, and we'll think, well, like, what can we help people with? What can we give people? What questions are people going to ask? Is there a logical second step? We don't always take that second step because the first step is often as far as we got. You know, nobody's taken this data set, put it online in this way. So there's a lot of step one in what you've seen, I think. Step two, I think, was with the heat map work that Mike was talking about for the Oakland crime, would be saying like, you know, okay, so I've seen these individual instances of crime, but was that really telling me about my neighborhood? I mean, for those of you maybe thinking that it looks shocking, the amount of crime in Oakland, I encourage you to look at the same data for where you live. It's pretty shocking in San Francisco. It's pretty shocking in San Jose as well. I don't know about around here, but yeah, like taking that and saying like, how's that actually going to affect me? You know, whether it's dividing that by the local population and saying like, okay, well, if I live here as an individual, how likely is crime to affect me? Or if I hang around here over time, how likely is crime to affect me? Or if I'm here at 3 a.m. versus 3 p.m., how likely is crime to affect me? Those are the questions we're starting to ask of the Oakland crime data sets. I don't think we've dug that deep with other data sets yet. And in terms of the in situ stuff, I think like if we'd started with a mobile phone view of these things first, we'd be asking those questions a lot sooner because you don't want the big picture view when you're there. You want the, you know, the immediate like 3 or 4 block radius at most.
Do you have any ideas for at least building tools that the community could start posing questions?
Absolutely. I think those heat maps are the first iteration of those tools, and I think the other iteration of those tools is the APIs. The fact that we give that data out, we're kind of hoping that other people will do that too.
Yeah, the sort of the model for that out there. There's a project in 2004 called Fundrace that IBeam in New York did, where it was the first like map view of FEC. Is it FEC? Political contribution data that was out there. And so, they basically stuck it on a map, and you can see like who in your neighborhood was doing $200 or more. And what somebody did with that data was they created a little Palm Pilot application that used GPS information to give you essentially like a get the hell out of Dodge compass. So you could like kind of look at this thing and it'd be like, oh, you're in a red zone, like head that way for more blue, or vice versa. You're in the blue zone, head that way for more red. So there's always this hope that if you release enough data, someone out there will do something interesting with it. It doesn't always happen that way. Maybe you're doing something like this on a data set that's of a really limited set of interests. So, I think just the fact that it's being made public in such a way that at some point in the next couple of years, somebody with an itch to scratch can look at this and say, okay, I want to make the thing for the iPhone, or I want to make the thing for, Fire Eagle, or whatever kind of locative technology you want to use. It's the data that's the real public good in this situation.
Should we leave it there?
Any more questions? All right, let's thank our speakers.
Thank you.
For more, please visit us at stanford.edu.